often we're actually interested in the equation of a line segment between 2 points, P naught and P. If we use the parametric equations, or the parametric form for the equation of a line, a vector equation of a line, and we let t equals 0, then we have P naught, because we're at R naught. So we have the position vector for the point P naught. If we let t equals 1, and then we have the position vector for the point P. Now, just as a quick reminder, the vector equation for that line is going to be equal to R naught plus t times A, or t times V, however you want to think about it. Let's go TV. Okay, to draw a quick picture again, basically I've got P naught, this initial point that we know, and over here somewhere I'm going to have the origin. So I'm going to have this position vector R naught. It's a position vector of the point P. And then I'm going to end up with some arbitrary point out here, P. And vector R is a position vector for point P. That means I've got vector V, which is my directional vector. This is vector A, which in this case is connecting P naught and P. So that's why we can think of A for any value or some specific value of t, A as being equal to t times the vector V. Now, if we take a look at our previous example, we had these coordinates. The initial point was 2, 4, -1, and we had this other point, 5, 0, 7. We have the parametric equations, x equals 2 plus 3t, y equals 4 minus 4t, z equals -1 plus 8t. So what I want to do is I want to think in terms of the line segment. So I'm going to use this vector r again. R of t is going to equal, in component form, 2 plus 3t, 4 minus 4t, that's no surprise, -1 plus 8t. But what I'm going to do is I'm going to restrict the domain of t. T is going to be from 0 to 1. When I restrict the domain of t, that's what gives me a line segment and not the entire line. So, in general, we know that the vector equation passes through the tip. Actually, I got a couple typos of the vector equation of the line passing through the tip. There we go. Of the vector r naught in the direction of v is going to be r equals r naught plus tv. So if the line also passes through the tip of r1, then we can write v as being r1 minus r naught. And that's going to give us vector r equals r naught plus tv, but v is r1 minus r naught. Now I'm just going to mess around with a little bit of algebra here, and I'm going to have, r naught equals t times, it's r naught, not equals, but plus t times r1 minus t times r naught, which I'm going to rearrange is r naught minus t times r naught plus t times r1, which is actually equal to 1 minus t times r naught. I simply factored out that vector, plus t times r1. And this is what I think of as the equation, the vector equation, for the line segment from, well, P naught to P, which we can think of as R naught to R, actually R naught to R1. If we restrict the domain of T being from 0 to 1. Now see, if you notice here, if T equals 0, this piece right here goes away. T equals 0, so all I have is 1 times R naught. So at T equals 0, all I have is the vector R naught, which is a position vector for my point P naught. When T equals 1, I have 1 minus 1, which is 0, so R naught goes away, but I have 1 times R1. And that's the position vector for that second point, P. Now, let's see here. Let's take a look at a quick example here. So I want to find the vector equation for the line segment that's connecting these 2 points. And remember, I can think of these as points because these are position vectors. I can think of point P naught, the initial point, as being 3, 1, 7, and that of course would give me R naught, and the second point as being 4, 2, 5, because that would then give me this position vector. So vector R is going to be 1 minus T times R naught plus T times R1, and I'm going to restrict T, which in this case is going to be 1 minus T times, well, R naught is 317 plus T times R1, which is 4, 2, 5. And of course, I don't lose sight of the fact that I'm restricting the domain of T. Now, see what happens when T equals 0. When T equals 0, I'm going to evaluate this real quick here for T equals 0. What I get is 1 minus 0 times the vector 3, 1, 7 plus 0 times the vector 4, 2, 5. That is simply the vector 3, 1, 7, which is the position vector for that first point. That's R naught. Likewise, if I evaluate this for T equals 1, what I end up with is 1 minus 1 times the vector 3, 1, 7 plus 1 times the vector 4, 2, 5, which is, this is 0, so that's just going to go to 0. That goes away. So this is nothing more than 4, 2, 5, which is the position vector for that point. So at the extremes, I'm at the 2 points that I'm interested in. So as T varies between 0 and 1, I will hit every point in between it. In other words, I just represented, or I just came up with the representation of the line segment from R naught to R1.